Okay, today we're going to be talking about special relativity, and one of the paradoxes is this idea of simultaneity. Okay, and this is where things are simultaneous in one reference frame, but are not simultaneous in another reference frame. Okay, and it's one of the, effects of having the speed of light constant in each reference frame and the speed of light not changing. What we usually do is we usually consider some train, okay, and we have the front of the train, the back of the train, and a person in the center of the train. Oops, I might just put C at the center there. Okay, and then we have someone standing on a platform, P, watching that train go by. For this case here, if we consider the person platform from the platform's reference frame, the train is moving to the right. If we consider the person in the center of the train's reference frame, P is moving to the left. Okay, so whichever reference frame we consider to take, we always consider them to be stationary. And so what we're going to see now using space-time diagrams is that the light, if it's simultaneous in C's reference frame, it will not be simultaneous in P's reference frame. And so let's start off by considering C's reference frame. And if we're considering C's reference frame, what we do is we put it in the center. Now in this case here, you notice I haven't got my rulers out, okay, because this is something you can do in your exam just to show, to use as a bit of evidence for your argument when discussing this paradox. Okay, so we put C in the center, and what we know is the distance between front and the back of the train don't change. Okay, this distance remains the same between C and B and F as you go through the train. And what we say is that we put turn some light bulbs on, okay, and C sees them reach each other, or both of them get to C at the same time. So what does that look like? At some point in time, we get a 45-degree angle coming from the front and the back. Why is it a 45-degree angle? Because it is the speed of light, which looks like this. Now, what this shows is that they arrive at C at the same time. Now, if we put what P is doing at this particular moment in time, P will be on a platform, okay, and as the train moves by, it'll look like moving through in this angle here, and it has to be steeper than the straight speed of light. Now what it sees, in this case for P, is it sees that it intersects with the front of the train first, and then later on it intersects with the back of the train. Okay? So depending where it is, where P is at any particular moment in time, it will not be simultaneous. I could have drawn P's reference frame over to the side here, and I would have got the same result, except this time it would have seen the light from the back of the train before it got through to the front of the train, from the light from the front of the train, and that's because the light was traveling in this direction. So all you need is one sort of example here, and you could draw this up, and what you're referring to in this case here is that there's some sort of change in time. It's not simultaneous in P's or in this case for P, but it is for C. All right, and now some people think, well, how about we look at it the other way around, which we can also do. What happens if we consider P to be stationary? And we're going to get the same result here. All right, and there's multiple results. I might just shrink this down a little bit. Is we can draw P as the world line, and that's the person on the platform, and we will see that the front of the train and the back of the train will be moving to the right, and that will remain equidistant with. So that's the front of the train, that's the person at the center of the train, and that's the person at the back of the train. So the key here is that light arrives simultaneously to C. So if this is the case there, all right, that light has to be drawn at 45 degrees there, and light is going to be drawn at 45 degrees down here as I go in that direction, all the way back down, and that's just to help extend later on. And so the key here is that it still remains simultaneous in C's reference frame, but let's have a look at the time where the light intersects P. And I'll need to continue to draw this in this direction because the light's going back to the left. Okay, so in this reference frame here, the light will intersect P here and intersect P here, and that will once again show that we have some sort of difference in time. Okay, so even though it's simultaneous in C, it remains not simultaneous for P. And in this case here, P sees the light from the back of the train first, and then sees the light from the front of the train a little later on. Once again, if we moved these lines across in that direction, all right, we might get a different result in terms of what we see for P, in terms of which one it does first. But at the end of the day, they'll always be different if they arrive simultaneously at C.